Good day everyone. We are the Team M. I am Daryl Ray Saluta
And I am Divine Cabigting.
and we are presenting our PowerPoint presentation.
In today's video, we will discuss our Project 1 CPU scheduling algorithm.
The group have discussed and decided to choose the multi-level feedback queue scheduling MLFQ. This algorithm divides the ready queue into smaller queues based on CPU burst characteristic. Processes are not assigned to one queue indefinitely and are free to pass between them. The queue level of this algorithm has two top-level queues, are both round-robin, and last queue level is first-come first-served FCFS algorithm.
So this study employs multi-level feedback queue scheduling, which enables a process to move between queues. The concept is to distinguish processes based on their CPU burst characteristics. When a task consumes so much CPU power, it is relegated to a lower priority queue. Similarly, a procedure that remains in a lower priority queue for so long can be transferred to a higher priority queue. So this form of aging prevents starvation. Besides of its concept, a multi-level feedback queue scheduler is the most common CPU scheduling algorithm. It can be tailored to a particular framework under development. Since the most common scheme is a multi-level feedback queue, it is also the most complex.
So as you can see, the key goal is to create a complete functioning application that demonstrates the MLFQ, multi-level feedback queues scheduling algorithm.
So the objectives are the number of operations, burst time, and arrival time can all be entered by the users. Because we're using multi-level feedback queue, we need to be able to display the completion period, turnover time, waiting time, and the average of TAT and WT. To be able to apply our MLFQ CPU algorithm using C programming, and to display the program's output, the command prompt would be used.
To be able to solve all of the dataset problems and applications that are presented, to gain a deeper understanding of CPU scheduling algorithm, especially the multi-level feedback queue, MLFQ, which is the most complex of them all. To be able to create a visual demonstration about how to overcome a program's multi-level feedback queue. The C and the C++ programming languages were selected by the group to introduce the multi-level feedback queue scheduling. A programming language is a compilation of commands, instructions, and other syntax for writing application. The languages in questions are medium and high-level languages that can process graphics in making the program output more presentable and appealing to the user who would run it. In addition, the group will use the C programming language to create a Gantt chart for the CPU scheduling.
For the number of process, the group have discussed and decided the minimum number of processes that the scheduling algorithm will be handling 5 processes, while the maximum number of processes that the scheduling algorithm will be handling 8 processes. For the burst time, the group have decided that the minimum burst time that the scheduling algorithm will require for a process will be the minimum of 1 millisecond, while the maximum is 30 milliseconds.
For the arrival time, the group have decided that the arrival time would range from minimum of 0 milliseconds, while the maximum arrival time that the scheduling algorithm will require will be 9 milliseconds. For the quantum time, the user enter in each quantum time in the top 2 levels of the queue level. The group have decided to use a minimum of 3 milliseconds as the quantum time and maximum of 5 milliseconds.
The output program shows the full Gantt chart of queue level 1, 2, and 3, and also for the final Gantt chart.
Furthermore, the process is highlighted with a different color to indicate where it began and ended.
That's all for today. Again, I am Divine Cabigting.
And I am Daryl Ray Saluta.
We are the Team M. Thank you for listening.